Hi students, here's your Spiral 17 review. We're going to start with problem number 1. We're in the world of graphing rational functions. And here we got to do some analysis of some asymptotes. For the first two we're talking about is x approaches negative infinity or is x approaches infinity. This is really talking about the horizontal asymptote if there is one, or really the end behavior. Here we do have a nice horizontal asymptote. It's what I see in green. What you see is a dashed horizontal line. I can't really tell what this is. This looks like a height of y equals 1 on there. I'm going to try to do a better job of making that visible on the one that you have printed out, although I really try to do that so we can see what these are, but we'll do what we can. And what we're talking about is, as we're going to the left, what's the y approaching? We're coming down to that horizontal line, so I'm going to call that 1. Same on the right side as we go to the right, so that's this other one. We're approaching a height of 1 as well. The second piece of this is x approaches negative 1 from both sides. This is from the right and from the left. So negative 1, that's talking about this asymptote. And from the right side, that's this one, we are approaching a negative infinity because we're going down. And then from the left side, that's this one, we do this in yellow. On here, we're approaching negative infinity as well. You're not asked at all about this purple asymptote, which again you guys see as a just asymptote. So you have to identify which one you actually care about for this problem. All right, for number 3, we're doing the same stuff we've been doing for quite a while now. We got to graph this thing, identify some special points. The vertical asymptote is whatever makes the bottom equal to 0. So if x plus 2 is equal to 0, that means that x is negative 2 would be my vertical asymptote. I'm just going to draw that in now. X equals negative 2. Horizontal asymptote, I'm going to plug in really big numbers, and that's going to make the 2 constant, the negative 1 and 2 go away, leave me with just 2x over x. 2x over 1x is just 2. So at positive 2, we're going to have a horizontal asymptote. For the x-intercept is about when y is 0. That's the same thing we've been talking about all year long. And in this case, if y is 0, if I multiply x plus 2 to the other side, that part goes away, leave me with just 2x minus 1 is equal to 0. You can shortcut this by saying that the numerator is equal to 0. So when we do this, we end up adding 1 divided by 2 to get x is equal to a half. And let me put that there. And then finally for the y-intercept, that's when x is equal to 0. And that cancels out the x's, leaving us with just negative a half there. And we get a lovely point here. All right, finally, nice smooth curve going through here. Hopefully your curve looks better than mine does, and the opposite one in the opposite corner. Next up, we got to simplify some rational expressions. And in this section, we are talking all about kind of the pattern that we do, which is to factor whenever possible, identify excluded values, and then either simplify or solve depending on what the problem calls for. And in here we're simplifying all these, and I gave you a nice handy-dandy checklist to help you kind of figure out if you're on the right track. For the first of our video ones, number 5, we are already factored, so I'm going to check that off. I need to identify some excluded values. We know that's based on anything that's in the denominator, so that means that 2x squared cannot equal 0, which tells us that x cannot equal 0. X plus 3 cannot equal 0, which means that x cannot equal negative 3. And then x minus 3 cannot equal 0, which means that x cannot equal 3. I have identified my excluded values. Then I've got to figure out what I can reduce here. And the first thing is that's much obvious, that's good grammar. That's very obvious to me, is that we've got an x plus 3 in the top and bottom, only multiplication in between. And then I notice that I've got an x on the top and the bottom, but here I've got just an x, and here I've got 2x squared, which is really 2x x. So what that means is I can cancel out one of those x's in the top and the bottom, leaving me with a 2x from that canceling. Okay, the only thing left on top is x minus 2. And on the bottom, we've got that 2x that was left over, and then x minus 3. At this point, you are done. I think it's the bottom one. Yep. I chose to do the dividing one to kind of help you guys with that if you need it. And the very first thing I'm going to do is do some factoring. And there's lots of stuff that's factorable here. X squared minus 16 factors into x plus 4 and x minus 4. X squared minus 25 factors into x plus 5 and x minus 5. 4 is not factorable, so I'm just going to leave that as is, a nice reprieve. And then the bottom part of this, x squared plus 11x plus 30, that's going to factor into x plus 5 and x plus 6. Okay, next up I've got to find some excluded values. I'm going to do that up top. X plus 5 cannot equal 0, which means that x cannot equal negative 5. That also happens to be in the second parentheses, or the second fraction, so yay. And then we got x minus 5 cannot equal 0, which means that x cannot equal 5. And finally, x plus 6 cannot equal 0, which means that x cannot equal negative 6. All right, those are my excluded values. Finally, I've got to use some simplifying stuff. I've got a division here, so I've got to do some flipping. The first fraction stays exactly the same, because we're going to keep it. And then we've got x plus 5 and x minus 5. We change the divide to multiply, and then we flip. And I'd like you to notice that when you do this, you have nothing new in the denominator, because the 4 doesn't have an x in it. This was done on purpose so you don't have to check for excluded values a second time. That's how these are going to end up working out. And I like that I wrote x plus 4 instead of x plus 5. That's supposed to be an x plus 5. And in fact, those are the only things that we have in common, so I'm glad that I checked that. And our final answer would be x plus 4, x minus 4, and x plus 6. And the bottom, I tend to write the number first, although it doesn't really matter when you have multiplication. We've got 4 times the quantity x minus 5. Next up, we've got to solve some rational equations, and we're going to start off with number 9. The very first thing I'm going to do, because I'm confused having a 3 over here, is I'm going to make that into 3 over 1. So now we are indeed all fractionified. The second thing I'm going to do, I really like the finding common denominator method of this. Nothing is factorable here. I do have to find excluded values. I'm using the checklist that you can't see below me, so I know that x minus 2 cannot equal 0. I did not do this out ahead of time, so I don't know if we're going to get that as an answer. I hope not. But then we got to find some common denominators. I know that I've got a 3 and an x minus 2. I don't need to worry about the 1. For the first fraction, which is 1/3, it needs an x minus 2, so I'm going to multiply the top and the bottom by that. For the second fraction, I am going to make that a plus. Put a minus 2 on top. That makes me less likely to make a mistake, although for this one it's actually a little bit easier because it's just a number. And we're going to have to, so that's x minus 2 already on the bottom. So we need times 3 and times 3 on top. Okay, then we've got equals. 3 over 1 has neither the 3, so it needs to be times 3, or the x minus 2, so it needs an x minus 2 as well. Wonderful. Let's do some simplifying. I'd like you to notice that all of my denominators are now the same. I can now ignore them. For the first one, we've got 1 times x minus 2, which is just x minus 2. For the second one, we've got negative 2 times 3, which is minus 6. And then on the side, 3 times 3 is 9. 9 times x minus 2 would be 9x minus 18. I'm going to bring the 18 to one side and combine some stuff. Negative 2 minus 6 is going to be minus 8. I'm just going to rewrite this before I start combining things. I'm going to add 18 to both sides, leave me with 10. Minus x from both sides, leave me with 8x. And when I solve that, I get x is equal to 10 over 8, or if you'd prefer, 5 over 4, or 1.25. And that is not 2, which was our excluded value that I don't think we actually ever finished solving up here. So we're actually in pretty good shape there. For number 10, we've got 3 over x squared minus 4, and we've got x minus 2x plus 2. I've given you a hint that if you have fractions like this, that means you can use the other pieces to figure out what you should factor into. But if you didn't get that hint, this is difference of two squares, and x squared minus 4 factors into x plus 2, and x minus 2. The nice thing about that is that now we've got 2 over x minus 2. I'm going to leave some space. I know I'm going to have to do some common denominators. And 3 over x plus 2. I know that I've got to have an x plus 2 in everything, so we've got that there. Now we're good here, and we already have it over there. I also need an x minus 2 in everything. We're good on the left side, so we need an x minus 2. And we know that if we do that in the bottom, we got to do that in the top, and I missed doing that on my x plus 2, so I'll put that in now. All denominators are exactly the same. We're going to cross them out. On the left side, we got 3. On the right side, we've got 2 times x plus 2, which is 2x plus 4. That's doing some distribution. And then we've got 3 times x minus 2, which is 3x and minus 6. All right, on the right side, we're going to have 5x minus 2. And on the left side, we've got 3. I'm going to add 2 to make 5 is equal to 5x, which means that x is 1. And I have no idea if this actually works because we forgot to do excluded values. Oh, no. So we're going to have x minus 2 cannot be 0. We're going to have x plus 2 cannot be 0. And that means that x cannot be plus or minus 2, which thankfully is not 1. So that one is actually all set too. All right, to the last page, and here we've got radical equations and graphs. This is our new section. This is the feedback section for this. The first thing we got to do is deal with some graphing stuff, and I did the video for the first one. So here we've got the equation of y equals the square root of x. That came out kind of funny looking, so I'm going to cover that. Radical, okay, that looks even worse, but that's fine. And we got to do some transformations. I've got 3 transformations going on here. This is a vertical stretch with a height of 4, so I'm going to write that here. So vertical stretch times 4. Really what that's going to look at is when you go 1 over, instead of going 1 up, now we're going to go 4 up. So that's the first piece we're going to play with. The second one is on the inside. This is going to be a horizontal flip. I'm actually going to do that part first so that we have something a little bit clearer to work with. And then finally, we were going to have plus 2 at the end. It's going to slide up 2. So if we were to combine these 3 things, we know this is going to be going backwards instead of forwards. It's going to be starting from up 2, so I'm going to take my 0 point and slide that up 2. I know that the vertical stretch times 4, instead of going up 1 over 1 to here, it would go up 4 over 1. But again, we're going to flip back the opposite way. So it's going to be flipped into the opposite side of things. If you really wanted a third point, the next one was at over 3 and up 1. Now it's going to be at back 3, 1, 2, 3, and up 4 more, 1, 2, 3, 4. And give us something that looks like this. Oh, heck, I might as well do number 14 as well. So here we're looking at a cube root function. And here we've got 3 transformations again. This is going to be going right 2, that comes from the inside, up 1 from the outside. It's going to be a vertical flip. So it's going to be upside down compared to this, and then times 3 for a vertical stretch. So just kind of looking at this, we've got some basic points at 0, 0, 1, 1, and -1, -1. And if we go, I'm always going to start with this inflection point. Over 2 and up 1, the new inflection point is going to be here. So that was this point. From here, I'm going to really just use this -3 to kind of help me figure out what's going on. This one used to be over 1, up 1. Now it's going to be over 1, down 3. This other point used to be down 1, back 1. Now it's going to be back 1 and up 3. So that my graph looks something like this. That's about as accurate as you need for any of these problems. The final part for 13 is finding the domain of this guy. I'm going to use the graph for that. My graph starts at 0 and goes to the left, so I could say that x is less than 0. Or if I want to use interval notation, I could say this is from -infinity to 0. Or I guess that would be less than or equals. Or x is all values less than 0. Anything like that makes sense. That's only where that graph shows up. For the range, we're going to look at the y value and go up from there. And it looks like we start at 2. And y would be greater than or equal to 2. Or if you want to use interval notation, it would be 2 to infinity. All right, number 16. We got to solve this equation. We've already got the square root by itself, so we know we got to square both sides. We got x squared is equal to x plus 2. We are going to have to look for extraneous values, and that's because we had a variable on this side. Whenever we have a variable over there, we will have to do this. I've also got an x squared and an x in the same problem. So I want to bring everything to one side, and that's going to give me x squared minus 1x. I'm going to put that coefficient there to make it easy to see. Minus 2 is equal to 0. This is factorable using a times c factoring. This is going to come out as x minus 2 and x plus 1. All right, and that's still equal to 0, so that gives me x minus 2 is equal to 0, or x equals 2, and x plus 1 is equal to 0, or x equals 1. Sorry, x equals -1. Woof, that's weird. So let's plug these numbers in and see which ones work. If I plug 2 in, we get 2 is equal to the square root of 2 plus 2. 2 plus 2 is 4. The square root is 2. That one works. If I plug -1, we get -1 is equal to the square root of -1 plus 2. And you might notice that here we have a positive square root and a negative value. That means that this does not work, that this value is extraneous. I am going to finish solving this just to kind of show us this. So that if you're not seeing that, that's okay. So here we get -1 is equal to the square root of 1. -1 is equal to 1, and that does not make sense. That's not true. And when we have a not true answer, that's when it's an extraneous solution.